So let us continue. Again I am repeating. Good morning. In this lecture we will discuss goal stack planning. In previous lecture I introduced you what planning is. If you can recall, we have seen that planning is the process of decomposing your problem into several sub-problems and then solving those sub-problems separately in a particular sequence to arrive at a specific goal. So we say that it's a process of computing several steps in problem solving process before actually executing them. So after executing a plan, you will get a set of actions that has to be performed to arrive at a certain goal. So if there are problems that you will come to know earlier, and so that your plan will take care of that, it will interact, and ultimately you are going to reach, you are going to achieve a particular goal. To understand planning, we are going to use a domain called as block world domain. In block world domain, we have seen there is a table. On the table there are similar type of blocks. They have similar shape also, size and shape. There is a robot arm and some initial state will be given to you, and you will have to achieve certain goal state. Robot arm will manipulate those blocks. Robot hand has certain capabilities, so we are going to define that as operations. So we will see those operations. So we will be discussing 4 planning techniques in our course: goal stack planning, plan space planning, graph plan, and planning with constraint satisfaction. So in this lecture we will study what is goal stack planning. Before understanding this goal stack planning, let us go through the block world domain again, because we are going to use that as an example to understand this goal stack planning. I told you that in the block world we have a table, we have set of blocks, they have similar size and shape. For example, 3 blocks are given, A, B and C. There is a robot arm. This robot arm only has to be used to manipulate these blocks. Robot arm can hold these blocks and place on another block or on table. So some starting state will be given to you and you will have to achieve certain final state. For example, you may have to achieve a state something like this. You want block C on table, block B on block C, and block A is on block B. So to get this goal state, this is starting state. What set of actions robot arm will perform so that you will get this goal state? So that will be the output of the plan, right? Now to do this, 4 operations we have defined which can be performed: stack, on stack, okay, and yes, along with this, pick up and put down, pick up and put down. So stack XY operation will place block X on block Y. Unstack XY operation will pick up block A or block X from its current position, which is on block Y. X and Y are variables. Okay. Pick up X, as the name suggests, will pick up block X from table. if X or block defined by variable X is on table, you can have pick up operation. So robot hand will pick up this block A. Put down, as opposed to this, put down operation will put block X on table. So naturally, block X, that means suppose X is A, put down A. So to perform this operation, block A, this robot arm should be holding. So these four set of operations you will have to perform, or you have to perform to reach to the goal state. So sequence of operations you will have to define. What sequence you will have to perform? We can easily make it out, but it's a complex problem for a robot. General real life situations are very complex, so accordingly you will be defining world knowledge, and you will be defining and performing operations. So to get this goal state, what operation you will have to perform? Robot arm will hold block A, so pick up A, right? And what another operation you will have to perform? You have to put this block A on block B. So stack operation can be performed for this. So stack operation requires this block A along with robot hand. So stack A B will stack this block A, which is along with the arm on block B. So two operations you need. One is pick of A. This will be a plan naturally that comes out if we do that ourselves. Pick of A and stack. You have to stack block A on block B. Okay, only these two operations you need to perform to get this goal state. Understood up to this point?
Yes, sir.
Okay. So output of this planning will be what set of operations and in what sequence you will have to perform to get the goal state. Now since we have brain, we can make it out. But you will have to write a program. Robot will do this. You give this objective to the robot that I want this goal state. So robot should decide what operations I should perform in what sequence. So output of learning will be this set of actions that robot arm will perform to get the goal state. Okay. Now to define this, we have defined predicates also. Set of predicates you need to define the word knowledge. On AB, we have defined on AB. What is this predicate? This will tell you that block A is on block B. On table A, we will define this predicate also. What is this? That block A is on table. Okay. Then clear A. Clear A predicate will tell you that block A is clear. That means there is no block on block A. That means like this. A is clear. There is no block on block A. Or another situation, block B is on table and there is a block A. A is clear here also. Right? This is clear A predicate. Holding A. Holding A will tell you that robot arm is holding block A. So this is equivalent to this. Robot arm is holding block A. Then arm empty. Arm empty, no argument to this. Arm empty, if it is true, that means robot arm is empty. If it is false, that means some other block robot arm is holding, right? So holding will check whether robot arm is holding block A or not. If it is holding block A, it will be true. So this five set of predicates you are going to use to define the world knowledge. And this four actions, these are what actions that you will have to perform to get the goal state. Now let us move further. Now understand what is a goal stack planning. This goal stack planning is one of the most important planning algorithms which was used by the system states, as I told you. And we have derived those actions and predicates only from states only. The stack is used in this algorithm which holds goals and actions. Remember this. You will have to use a stack, and that stack will store goals and actions uh, that satisfy the goal. Okay, final goal that we have to achieve. And you are going to use a knowledge base to hold the current state and actions. Now this goal stack is what? Goal stack is similar to a node in the search tree, where the branches are created if there is a choice of action. Okay, so you will have to visualize this goal stack which contain a set of goals and actions. Goals with sub goals will be there and set of actions. So that is just like a search tree, and at the junction you will have to make a choice. Okay, so what we do in this method, we use a single stack that will contain goals and operators. Operators means actions that have proposed to satisfy these goals. So we will start with empty stack, and the final goal that we have to achieve, that we will put on that stack first, and it may contain sub goals. To satisfy the sub goals, we will have to perform certain actions. So we are going to put them on that stack. Okay, once that sub goal is satisfied, you are going to remove those actions. Okay, and this you are going to do until the goal stack is empty. So what we do, uh, we are going to use a database. This database will describe current situation, set of operators described as PAD, as I told you. Every action will have set of preconditions which has to be satisfied. Then add list, that add list will contain the predicates which will be true after execution of that operator, and delete list, the delete list will contain the predicates which will become false after execution of that operator. Okay, so this goal stack planning attacks problems in while cojoined goals. Then we solve those sub goals one at a time in specific order. So that generates a plan, and that plan will be a sequence of operators for attaining the first goal, followed by complete sequence of operators required for achieving the second goal until the final sub goal. At each succeeding step, the top goal on the stack will be pursued, because it's a stack. So whatever is on the stack, that goal you will have to pursue first. Once it is satisfied, then next goal that will be on the top of the stack. So that has to be pursued. So in this way you are going to repeat until the stack is empty. That is what the process is. Simple. When sequence of operators that satisfies is found, that sequence is applied to the current state description that yields a new state description as usual. That's what we do in state space search also. Next, the goal that at the top of the stack is explored, and we try to satisfy it starting from the situation that produced as a result of satisfying the first goal. And as I told you, repeat this until the stack is empty. Stack is empty, that means you have got the set of operators, sequence of operators which will achieve the goal. Then as a last check, one more step you will have to perform. The original goal is compared to the final state derived from the all parts of the goal are reinserted onto the stack and same process will be resumed. So better understand this with the help of example. We will apply this process, goal stack planning process on the block world problem. Okay. So we have given starting state which is shown on the left hand side. There are four blocks A, B, C, D. A, C and D are on table and block B is on block A. This is the starting state given to you. You have to achieve this goal state. What we want? We want A and D will be on table and block C is on block A and block B is on block D. Along with this, of course, there is a robot hand. Right? So now what goal stack planning will do? As I told you that you define this situation first. Then goal state that you will have to achieve, define it by using knowledge representation that we have you are using. So first order predicate logic we are using for describing situation. So goal state, how to define it? Here block C is on block A. So on predicate we have, so I have defined that as C is on A. Then B is on D, so on BD we have. Then A is on table and D is on table. So on table A, on table D. So this is describing the goal state. This is what the goal that you have to achieve, right? So that we have defined in the form of first order predicate logic. Now you have to satisfy this goal, right? So put this on the goal stack. So this can be done in two ways. Suppose this column, first column that is defining one goal stack. So I have defined that C is on A, B is on D, and A and D are on table. So instead of writing two separate predicates, shorthand notation I am using on table A, on table D, that is equivalent to on table A, D. So I have combined just for writing. I have used shorthand notation OTAD, that is on table A, on table D. So this is what the goal is. You have to satisfy this goal. To satisfy this goal, now this can be done in two ways. One way is you first solve this on CA first and then on BD. Try to satisfy on CA, then on BD, and then on table AD. Another way is on BD also you can first satisfy and then on CA. So reverse sequence. Both ways you will get the solution. Either you solve the problem in this first alternative or with second alternative. Either of this will work. So what basically we are doing, we have put this goal on the stack. So that has resulted in sub goals. So this was the original goal. So sub goal is on CA, first sub goal, second sub goal on BD, and third on table AD. Otherwise, another alternative is on BD, you attack first, try to satisfy on CA, and then on table AD. Either this way, alternative 1 or alternative 2. Both will lead to the solution. Okay, understood up to this point?
Yes, sir.
Now, which one you are going to prefer? Now let us come to the alternative 2. Alternative 2 is saying that you first satisfy on table BD. Sorry, B is on D, not on table BD. B is on D. So how to make B on D? This is the starting state. Which operation you will have to perform? If you want B on D,
First pick up and then stack.
correct. Pick off and stack. Then to satisfy on CA, set of operations,
Pick up C and then stack.
stack C on A. Correct. So it's simple. If you consider alternative 2 and on table AD is already true, right? A is on table and D is also on table, right? So they are already true. So if you select second alternative, it is one. Trivial means it is simple, no complexities are involved. But we do not know which of alternative we should, that means robot will select. Robot does not know that beforehand that which one is easier. Okay. So to understand this goal stack planning more clearly, instead of attacking this problem with alternative 2, because alternative 2 is straightforward, just you can make out how the operations has to be performed. Simple set of 4 operations that results in the goal state. So instead of working on this alternative 2, we will work on alternative 1 so that we can understand the complexities involved in this planning technique. Okay? Because on CA, how to perform on CA? Consider the alternative 1. You want on CA, you have to satisfy on CA. That is C is on A. So directly that cannot be done because B is on A. Okay, so you cannot put this C directly on A. So more steps are required, right? Therefore, alternative 1 is interesting as compared to alternative 2. Alternative 2 is very straightforward. So we will work on alternative 1. Therefore, here what we will do, uh, uh, on table A and on table D, they are already true, so we will not work on them. Starting state. Define the starting state. Now, starting state is B is on A, that is given. A and D, they are on table. A is on table, D is on table, B is A. C is also on table, right? And arm is empty, that is also given. So arm is empty. So that is the starting state. Goal state is alternative 1 we are working on. So on CA and on BD and A and D, they are on table. So this is the goal that you have to achieve. So you are going to start with this. Given this starting state, because goal, you are in goal stack planning, you put goals on the stack. Okay. So start with the goal, that is on CA, on BD and A and D on table. Move further. 4 set of operators we are going to use. So I will repeat this again. In last lecture we have discussed stack XY. This operation stack block X on block Y. So for every operation we have defined precondition which has to be true to perform this operation. D means delete list. After performing this operation, what set of predicates will become false? So that set. And A means add list. After performing this operation, what set of predicates they will become true? That will be A list. ठीक है. So if you perform stack xy operation, stack block x on block y. So x and y are actually variables. You can substitute them with actual block names. Stack AB. So what stack AB will do? Stack AB will place block A on block B. So what is this situation? To perform this operation on table, uh, you will have block robot arm should be holding block A. After performing this operation, output will be block A is on block B and arm will be empty. So precondition is B is clear, there is no block on block B and arm is holding block A. So this is the precondition. After executing this, result is block A is on block B, so on XY, and arm is empty, arm is empty. After performing this operation, what set of predicates they will become false when they were true, earlier they were true. Clear Y will become false because B is not clear now, and holding X will become false because robot arm is not holding anything now. ठीक है? So this is stack XY operation. Similar to this, we have unstack XY. So if this is your current state, for example, block B on table and block A is on block B, this is the requirement for unstack operation. Unstack operation, what it does, it pick up block. Suppose you substitute X and Y with AB. So unstack AB will pick up block A from its current position on block B. Right. So precondition is X A is on B on XY. A is clear, clear X, and arm is empty. This arm is empty. After performing this operation, output will be block B will be on table and robot arm will be holding block A. Arm is holding block A. This will be the result of performing on stack AB operation. So add list will contain holding A and clear B. So therefore in add list we have holding X and clear Y. In delete list, on XY will become false because A is not on B and arm is not empty now, so this is false. Okay, so this is on stack XY operation. Understood up to this? Got how to define PDA for stack and unstack, preconditions, delete list and add list. So if there is no difficulty, move further. Pick of X. What is this pick of operation? That will pick up block A from table. Pick of will pick up block A. Suppose X is A from table. There is a robot arm. Pick up block A from table and it will hold it. So after execution of this operation, uh, arm will be holding block A, right? So requirement is, precondition is A is clear, otherwise you cannot perform. Be on table, A should be on table and arm should be empty. All are satisfied here. After performing this, arm will be holding this X, right? Arm is holding this A. What will become false? Find from this. So on table X will become false because A is not on table now and arm empty. was true, now it is false. So therefore arm empty is false. So that is pick of X operation. Similar to this, now put down. What put down does? That will put block A down on the table. So put down A, suppose. So for this purpose, I must be holding this block A. Then and then only you can perform this operation. If you do this at the output, you will get A is on table and R will be empty. So this is start state for performing this operation, and this is the final state after performing this operation. So put down A requires that arm should be holding this A. Delete add list will contain that A will be on table, arm will be empty, and delete this holding A will become false. Right? So this four operations we will be performing uh, to achieve the goal state in block world domain. Right? Understood up to this? Any doubt? Any question on this? There is no question. Move further. The alternative one we are tackling. So we have stack CA. On CA, let us go back. On CA, this we have put on the stack. On CA, on BD, and A and D on table. Come back here. On CA, on BD, A and D on table. So on BD and before that on CA. Now to perform on CA, out of four operators, look at this. The previous goal stack was on CA, on BD, and this as it is. Okay. Now you have to satisfy this goal on CA. To satisfy on CA, now how robot arm will find out? The process is, out of the four actions that we have specified, find out how you are going to get this on CA true. So go back. Now remove this. What we want? We want this on CA true. So find out which action that I should perform so that I will get on CA true. So you check result of, that means add list of all these four operations. Add list of stack xy, add list of pick of x, because what add list specifies? Add list specifies the set of predicates which will become true after performing that operation. So you find out which action should be chosen so that on CA is true. So let us start with stack xy. Out here we have on xy. So on CA I can substitute out here. So y is A and x is C. A, C and C. Let us come to pick up x. No, on CA we don't have, on CA we don't have. So there is only one option, stack xy, that is stack CA. If I perform stack CA, then I will get on CA, right? That predicate true. Are you getting?
Yes, sir.
What we are trying to do? We want on CA we have to satisfy on CA true. To satisfy this, program will see all these four operations, their add list where this on CA is true. So substitution will be performed. So we come to know that this add list of stack CA contain on CA. So this operation if I apply, then I will get on CA true. So what we will do, we will apply stack CA as the first operation. So therefore stack CA has been added onto the stack. Okay. Remaining stack will remain as it is. This was the earlier state on BD and this was your original goal. Now next step in goal stack planning will be satisfy stack CA. Try to satisfy this stack CA. So again the same process you will have to repeat to satisfy stack CA. The preconditions for stack CA are to satisfy this has to be true, clear A and holding C, right? So therefore put them on the stack. So clear A and holding C, clear A and holding C we have put on the stack. So first clear A and then holding C. One way of doing this is, again I am repeating, we want on CA true. To make this on CA true, we come to know that stack CA operator or action can be performed. So we have selected that action. To perform this action, we know that preconditions are clear A and holding C has to be true. So clear A and holding C has to be true. Put them on the stack. One by one try to satisfy them. Clear A and holding C. ठीक है? Understood up to this? Yes or no? If
Yes,
no,
sir.
you can ask me, interrupt me at any time. So first we have to satisfy clear A and holding C. You may say that why not holding C first? Another alternative is holding C first and clear A then after that clear A. Right? You are right. This way also it can be done. But now here you will have to use the heuristic. Heuristic is that holding is one of the several goals to be achieved at once. Because to perform any action, you will find out that robot arm has to be used. And if robot arm is occupied, then there is high possibility that you are not going to perform, you will not be able to perform any operation. So to perform any operation, most of the time you will find out you will have to use robot arm and that arm has to be empty. So rather than performing this holding operation first, always the heuristic is you perform it at the end. Don't engage robot arm. Keep it empty. So if we have options and if there is one of the alternative is holding operation, so keep it at the last. So therefore, instead of executing this holding C first, we will first tackle clear A and then try to satisfy holding C. Otherwise, unnecessarily again robot arm has to empty the robot arm or put the block which robot arm is holding on some other block or so on the table and perform some other operation. So instead of doing that, always keep it at the last. So we will prefer the sequence holding at the last and the first clearing. Okay. So go further. Now try to satisfy clear A. Go back again. Clear A. Now you will have to satisfy clear A. Now to make this clear A true, find out action that you have to perform. Go back to the operators. Clear A. So you go to the add list of all these four. You will find out that this is the candidate. So unstack operation. This corresponds to unstack operation. Clear Y. We want clear A. So replace Y with A. And what about X? B is on A, na? So this X replace B with X. X with B. So that will become unstack BA. Okay. So if you perform unstack BA, you will get clear A. So to get this, I should perform unstack operation. To perform unstack BA operation, this precondition has to be true. Now what is this? X is what? B, A, B. Okay. So on BA should be true. Clear B should be true and arm should be empty. So on BA, clear B, arm empty. On BA, clear B, arm empty. This has to be true. So first we put all the sub goal on the stack. On stack operation we have selected. After stack, unstack. Then these are the preconditions which has to be satisfied. So one by one you put them on the stack. On BA, clear B and arm empty. Understood up to this? How we got this? This is a goal stack now, right? Any question up to this? Yes or no? If no, let me know where we have problem. So shall I move further?
Yes, sir.
Okay, again I am repeating. First, to satisfy on CA, we got that stack CA has to be performed. To perform stack CA, you need to perform one stack B. Okay. To perform unstack BA, you precondition is on BA, clear B and arm empty. So all these sub goals we have put one by one on the goal stack. Now one by one try to satisfy this. On BA. On BA, is it true? On the left hand side,
Yes.
it is true. So it is already satisfied. So remove this from the stack. Okay. Clear B. Is B clear? Is there any block on block B?
Yes, sir.
Yes, B is clear.
No.
Is clear because there is no block on block B, right? So remove this from the stack also. Arm empty. Is it empty? Arm is empty?
Yes.
Yes. So remove this from the stack. All three are satisfied. Once it is satisfied, we should remove that from the goal stack. This will be done automatically by your program. Okay. So that will remove this. So that means you can perform unstack operation. So unstack will be performed and result of execution of this will be arm will be holding block B, right? Arm will be holding block B. Go back to the result of unstack. Holding B and clear, right? Result of exit clear A. Arm will be holding this and A will be clear in that case. ठीक है, move further.
सर होल्डिंग बी पाहिजे ना तिथे.
Here arm is holding B, no? Right, so arm is holding B. This corresponds to stack CA operation. This holding C. Go back. First, you are satisfied on CA. To perform on CA, you have to perform stack CA. For stack CA, requirement is clear A and holding C, right? So clear A and holding C, they are on the stack. So this corresponds to this stack operation. So clear A, to perform clear A, you will have to clear A. You will have to perform unstack BA. So unstack BA you are performing. To perform unstack BA, what you need? On BA, clear B, arm empty. So on BA, clear B, arm empty. Understood?
Yes, sir.
Right. So that holding C is corresponding to this stack CA, result of this. Okay. Now here all three are satisfied, so remove them. So as of the okay. So we have popped all this. We can pop predicates on the stack till holding C, for which we need to find out the suitable operator. So we have popped this. Okay. All these are satisfied. So we have removed them from the stack. So holding C now you will have to satisfy. So holding C has to be true. Now goal stack will look like this. I have removed all those sub goals which are satisfied. Arm is holding block B. Arm is holding block B, right? So arm is holding block B. Now your world knowledge will be like this, and this is the goal, same, and this is the goal stack now, right? Now next job is how to make this holding C true. Now the world model, that means database, will contain A is on table, C is on table, D is on table. On table A, C, D. Arm is holding B and A is clear. Okay, this is the world knowledge. So find the suitable operator which will make holding C true. What are the operators, or what is the operator? Go back. When holding C is true, let me remove this. Holding C, look at this. This one is one candidate and this one is another candidate. Either you can perform pickup X operation or you can perform unstack XY operation. Right? There are two candidates now. Understood? So program will find out here that it has to perform either unstack XY operation or pickup X operation. X means C. Unstack C and value of Y, pickup C. Understood this? There are two candidates now, either this or this. because add list of both these operations contain holding x. So replace x with c. Understood this?
Yes, sir.
So now here heuristic has to be used. You need to use the heuristic. That's why we have considered this alternative 1, because 2 was very straightforward. Here we are in a situation that there are two alternatives. Okay, so without looking ahead, this and this is alternative 2. In alternative 1, we have used pickup C, and in alternative 2, unstack CX. Go back. Pickup C and unstack CX. Okay, so now there are two branches. Here decision making has to be made whether you should go to the alternative 1 or by alternative 2. So which one has to be selected? So some heuristic information has to be used, knowledge has to be used to decide on this. So you will find out this alternative 1 is better. Pickup C is better than unstack CX. Why?
Uh,
What might be the reason? Two options we have. One is pickup C and another one is unstack. So I said that pickup C is better than second one, that is unstack CX. Or what do you think? In unstack CX, X could be any block from which C can be unstacked, right? Without looking ahead, you cannot tell that which operator is appropriate. But if you perform look ahead, you will find out that is alternative 2. Now gold stack, now it will contain variable x, unstack cx, because of that unstack cx. So you will find out that x appears in three places. Go back. This x appears in three places. Although any block could be substituted for x, now it is important that same one can be matched to each of x. So x should be the, therefore you will find out it is important that each time the variable is introduced on the goal stack, then it will be given a name which is distinct from any other variables that are already on the stack. So this is the complexity involved, but that will be handled automatically by your program. And whenever uh, a candidate object is chosen to match a variable, the binding must be recorded. In unification algorithm, we have seen that substitution has to be carried out throughout, so that the occurrences of same variable will bind to the same object. Now, how our program should choose between alternative 1 and 2? We can tell that picking up block C, picking up a block C, first what you will have to do, you will have to stack it. Picking up block C, go back, pick up operation. For pick up operation, that block should be on some other block, right? Let us recall the pick up operation. Pick up block A from table and hold it. You can do that, but that will waste of efforts because program will not be knowing that. Suppose you do alternative 2 first, where that is on stack operation, to satisfy that on CX, uh, this on CX. To satisfy this, you will have to stack C on block X. Okay, you will have to C on X. Now, right now it is not. So, therefore, that will be unnecessarily waste of efforts. So, if you select alternative 1, in that particular case, you find out, you do this at home. You pursue this alternative 2 and you will have to first satisfy on Cx, that is C is on X, and you will find out C is not on X. So you will have to first put this C on some other block, right? Uh, and then you will find out unnecessarily you are wasting your efforts. So therefore alternative 1 is better if you perform look ahead. So now if you tackle this alternative 1, now goal stack will be clear D, holding B, clear D and holding B. Because of what? Stack BD operation. How you got this stack BD? Come to this. Pickup C you have performed. To perform pickup C, you need to satisfy this on table C, clear C, arm empty. On table C, clear C, arm empty. So C is on table, C is clear, but arm is not empty. So find out the action which has to be performed to make arm empty true. So go back. So arm empty is true. There are two options we have: stack xy, put down x. Okay. Now how come this? Now alternative 1, recall alternative 1. In alternative 1, which has used pickup to give arm holding C. Now goal stack top element is on your goal stack on table C, right? This is at the top, which is already satisfied. C is on table, pop it off. So remove this. The next element is clear C, which is also satisfied. So remove this. C is clear out here. C is clear. So remove that. Remaining precondition is pick up C is arm empty now, which is not satisfied because holding B is true. Go back, holding B is true. Now there are two operators which can be applied, stack Bx and put down B, as I told you. Stack Bx and put down B, because here arm empty, out here also arm empty. In other words, now we can say that we can either put B on table or we can put it on D. Now it would be most efficient simply if we put it there now. But how your program will come to know? It will compare the elements of the add list with the rest of the goal stack. If one of the operator has effect of making any of this, then we will choose that. So you will find out stack BD by binding D to X. Therefore here stack BD is chosen. Right, operation will become stack BD now. Substitution has to be carried out. Why we have done that? To get that arm empty. So you are performing by look ahead this stack BD first, so that arm will be empty. So two things you are performing in one shot. So B will be on D, right? And arm will be empty. So goal stack will look like this. Now to satisfy this stack BD true, what is required? Stack BD, B and D. This is D, this is B. Clear D and holding B. Clear D and holding B. So therefore clear D and holding B. Okay. So therefore the goal stack will look like this. Any question up to this?
No, sir.
Two alternatives were there. We find out that stack Bx was the better alternative. Substitution will be carried out and stack BD will be chosen. And to satisfy this stack BD, precondition is clear D and holding B. So try to satisfy clear D and holding B. So clear D is true. So remove that from the goal stack. Holding B, both are true. Holding B is also true. So stack BD will be performed. So B will be on D now, right? Arm will be empty after performing this, right? Are you getting? So this will be removed from the stack. So now M is empty now. Pickup C can be performed. So pickup C operation will be true in that case. So it will be satisfied. So it will be executed. So preconditions of stack CA are true now. Clear A and holding C. Both the preconditions. This will be holding C then. Then stack CA can be performed. So remove this also from the stack. Okay. Understood up to this? So what will be the output? C will be on A here. B will be on D. Then on BD, what about this? But it is already satisfied. B is on D. So this will be removed from the stack. Okay. So stack will be empty now. All this C is on A true, B is on D true, A and D are there on table. So stack will be empty now. So this completes the execution of algorithm, and that tells you that you will have to perform these operations in this sequence so that you will get this particular goal. So the problem solver will halt and it will return a plan on stack BA, stack BD, pick up C and stack CA. How you got this? This. On stack BA, first on stack BA, then stack BD, pick up C and stack CA. Look at this shown in brown color. So these are the operations that has to be performed, and that is the sequence in which those operations will be performed to get the goal state. Okay. So this is how this goal state planning works, and algorithm will return this set of actions, that in this sequence you perform the action so that you will get the goal state. So let us summarize this. The planning method that we have discussed is linear. Linear means what? It satisfies some goals sequentially, one by one after another. Therefore, it is not very efficient technique. So if you choose alternative 2, for example, go back, then immediately you will get the result. I told you that alternative 2 is immediately here you will get the result. But alternative 1 is the longer path. We have discussed alternative 1. But beforehand, we don't know whether alternative 1 is better or alternative 2 is better. So program will not be able to find out which one has to be selected first. Therefore, I said that it is not efficient. Okay. So this is about all about goal stack planning method. In next class, we will discuss the remaining technique. Thank you. Good day. Am I audible now?
Yes, sir.
Okay. So I will put this lecture on YouTube. So the part which you could not hear properly, that you go through that recorded lecture. Okay.
Okay, sir.